so really don't have a whole lot today. Do we feel we've got a pretty good grasp on this material so far? Okay, and if we were to do, okay, let me start over, because I think it's better to see this rather than just try to visually talk about it. What I mean is something like this. We'll say, keep it simple. All right, so that bottom reaction, we'll start with that one quickly. The first thing that we want you to start with and recognize, okay, what type of, I shouldn't have wrote the word out, but just looking at that 2-butene, is that an asymmetrical compound or symmetrical, do you think? And some of you maybe can't picture that until you see it, and that's fine. I should have wrote it like this instead. But does anyone know? Okay. Because we had 2-butene, so does that look like it's symmetrical or asymmetrical? It is symmetrical. So the first thing that we want to recognize in these type of reactions, first, look at your reagent. Is this symmetrical or asymmetrical? Yes. What type of reagent is this, symmetrical or asymmetrical? It is asymmetrical, so of course what that means is that this splits in half, okay? Now, what happens with that is, do we get one? We do get two products with this, but is there a major and a minor? No, there is not, okay? And that is because when we draw this, okay, that double bond has broken. And where would you like that chlorine to go? The second or third carbon, left or right? Okay, so we can put that chlorine here, which means, okay, whoops, well, it should go up top with him so it mirrors what's on the other side. So we can put that chlorine up here, therefore that hydrogen has gone down there, because that's where we can actually bond that. Now, this forms probably about pretty close to half of it. And it just so happens, even if you did flip-flop those, you're still going to get 2-chlorobutane. Okay? Now, that's different, however. Is there any questions over this? It's been a little over a week since we've seen this. I don't want to try to get through this so fast that we do that. It's kind of like, oh gosh, I'm glad we got done, but I have no idea what we're doing. So left side, are we good? Middle and right side. Okay, now this would totally change everything if this is what we were to do. Okay, now this parent chain, is it symmetrical or asymmetrical? I was just seeing if anybody was paying attention. Okay. So is this symmetrical or asymmetrical? It is. So this is asymmetrical. This is asymmetrical. Now you're going to get a major and a minor product. So my point is, just like what we've done in the previous section, we want you to recognize, okay, is this symmetrical or asymmetrical? And then finally, what is your parent chain that you're reacting that with? Is that symmetrical or asymmetrical? Okay. We also want you to recognize then when we are working with these compounds, these aromatic reactions, okay, the first thing that you look at this, do you think you get one product or two? You do get two, Okay, so when we actually know what we're supposed to get, and some of you might be questioning, I don't know how you came up with that, and that's fine, okay, because we're working on this together. What that means is, what is aniline? Yes, it's an aromatic compound. Okay, and when you draw these, to make this the simplest for yourself, don't try to, well, you can. Don't try to be fancy and put NH2 down there, over here. Would you agree? The best place to put that would be up here. You can put it on the bottom too. There's absolutely nothing wrong with that. Reason for that is, once we add bromine, okay, is that it? No, you're correct when you're nodding your head. Because remember, this is diatomic, okay? This just means an acid catalyst, sulfuric acid, okay? Now, this is different than just simple halogenation. Halogenation just means you're attaching this bromine on here, okay? But this is already occupied by an amino group. And when you look at that upper left-hand corner, what we had said, we want you to recognize if there is something on that ring already, which there is, this is going to tell that bromine where it can bond to. And when you said two products, yes, you were correct when you said that. Okay? So what that means NH2. Does anyone just start over when they don't like the way it looks? Anyone's nodding their head yes. Yeah, okay. I do too, yeah. So that amino group is going to tell this bromine where it's going to attach. And when you said two products, that's right, because this is what type of a director. We said there's two. Just guess. That's one. Nope, not meta. It's ortho and para directors, okay? So now what that means, we'll just go ahead and where's an ortho position for this? Okay, so left or right. Okay, because we said one away, so that's either here or here. That's why we're saying left or right. We said left. Okay, and then left or right for this one. It doesn't matter, because if it's in the para position, it's straight across, because that means it's 1 and 4. Okay. All right. Left side, are we good? Middle? Right side. All right. We said we're going to keep this short. I don't know if we said. You know, I think if I don't say we're going to keep this short, we do. And then if I say, I don't got a whole lot for you, and then about 10 minutes after 9, we say, oh, that's enough for today. So, yes, that's all we wanted to cover today. If we're having any issues, please talk to one of your classmates or give me a holler. All right. We'll catch up to you next time.